So after reviewing what solving for substitution, we're going to go ahead and continue on solving by elimination. Now, in solving by elimination, there's just a couple of things that you need to look for. So in order to use it, what you're going to have to make sure you have, it's the same variable, the same number, but different signs. So that's when you are better off using elimination. So use elimination when you have the same variable, the same number, but a different sign. So that means that one is positive and the other one is negative. So let's look at the first example. So we have 4x plus 2y equals to 9, negative 4x plus 3y is equal to 16. So let's look at this problem. So do I have the same variable? That means either look at the x's or look at the y's. Then with the same number, this guy has a 4, negative 4, a 2, and a 3. So who has the same number? The 4's for right now. One's a positive, one's a negative. In that case, it looks like we're looking at the 4's. So by looking at 4x, we're going to look at this as a big math problem. So what is 4x minus 4x? Like you see right there, they're cross. So then we're going to add the rest. What is 2y plus 3y? Well, 2 plus 3 is 5, so that right there becomes a 5y. And what's 9 plus 16? 9 plus 16 is 25. Now, if I want to solve for y, since 5 and y are being multiplied, I would have to divide 25 divided by 5. That tells me that y is 5. So you have found one answer, and just like in substitution, we have to plug it back into one of the original ones or one of the other equations. Same thing here. So we're going to go ahead and plug in the 5 into, I always like to go for the first one. So we're going to go in there. So this is 4x plus 2 parentheses 5 equals to 9. So from there we have to work with it. So the 4x comes down, 2 times 5 is 10, and it continues to be equal to 9. Make sure you keep all the problems together and you don't put a 16, you don't make a mistake. So in order for me to solve for x, I would have to get rid of the 10. Now the 2 10s cross out, the 4x stays, and 9 minus 10 would be a negative 1. We now divide by 4, so then x is a negative 1/4. So then my order pair here would be negative 1/4, comma, 5. Now let's look at the second example. Another one that's going to be more than likely ready for us to eliminate something. So we have x plus y is equal to 12, and x minus y is equal to a positive 2, sorry. So when you look at this, look at the x's and look at the y's. The x's have a 1 in front, the y's have a 1, but who has one positive and one negative? Well, obviously it's the y's. So we're going to go ahead and they're ready to get rid of them. So please don't forget the x's have a 1 in front. So what's 1 plus 1? 2x. And 12 plus 2? That right there would be 14. I would divide by 2. 14 divided by 2 is 7. So now go plug in that 7 into the other equation. So I end up with x, which is 7, plus y equals to 12. So if I want to solve for y, subtract the 7, 12 minus 7, well that right there is 5. So this would be my new order pair, 7, comma, 5. Now, sometimes you cannot, with the equations they give you, you're not going to be able to eliminate your answers. As easy as an example 1 and 2. So we have 4x plus 2y is equal to 4, and 6x plus 2y is equal to 8. So first thing that we need to think about here is we need to look at your numbers. So we have a 4x and a 6x. We have a 2y and a 2y. Who's closer to what we need? Same variable, same number. Well, apparently it's the 2y's. So we're going to have to work with these guys. Now, the only thing that they're missing is, remember, one of them has to be a positive, one of them has to be a negative. So different signs. So this is why I'm going to take the bottom equation and I'm going to just multiply it by a negative number. So the top equation, nothing happens to it. I'm just going to rewrite it just the way you see it. 4x plus 2y is equal to 4. The only one that we changed was the bottom one. So we distribute the negative to everything. So that becomes a negative 6x minus 2y is equal to a negative 8. Now that I've taken care of that, do you have the same numbers, same variable, one positive, one negative? We sure do. So then I'm going to look at the 2y's. Those cross out. So then I'm just going to take care of the addition and subtraction of everything else. 4 minus 6, well, that's a negative 2x. 4 minus 8, well, that's a negative 4. I'm solving for x, so I would have to divide both sides by a negative 2. So x is negative 4 divided by negative 2 is 2. Now this 2, I have to go and plug it in either to the top or bottom one. Like I said, I always just stick with the top one. So I have 4 times x, x in this case, well it's 2, what we just got, plus the 2y is equal to 4. Now I'm supposed to go ahead and do the mathematics. 4 times 2 is 8, plus the 2y is equal to 4. Now we're going to go ahead and solve for y, so we need to make sure that we leave the y by itself, so I would subtract 8. So that's 2y, 4 minus 8 is a negative 4. Divide both sides by a 2. So negative 4 divided by a 2 gives me y is equal to a negative 2. So my answer, 2, negative 2. So let's go ahead and look at the next example. So we have 2x plus 7y is equal to 4, and 3x plus 5y is equal to a negative 5. So first of all, I need for you to analyze what's going on here. Look at the 2x, look at the 3x. 2 and 3, not even the same number, but of course both of those are x's. And then 7 and 5, not the same number, they both have y's. So right now we're just looking, hey, the only thing that they have according to what we're supposed to look for, which are those three things, same variable, same number, different signs. Now, when I look at 2 and 3, what is the smallest multiple they both multiply to? Well, 2 could become a 6, and 3 can also become a 6. So both 2 and 3 could become a 6. But when we look at 7 and 5, now 7 and 5, the only multiple that they have in common, the smallest one would be 35. Now the question would be, would you rather work with a 6 or a 35? Hopefully you're saying with the 6. Now in order to make the 2 a 6, I would have to multiply it by 3. In order to make the 3 a 6, I would have to multiply it by 2. So I'm going to go ahead and multiply the top one by 3 and the bottom one by a 2. But not just a 2, but in this case a negative 2, because I would need a positive and a negative number. So when I put the 3 outside, 3 times 2x, well, that right there is a 6x, which is coming up. 3 times 7y, that's a 21y. And 3 times 4, well, that's a 12. The bottom one, negative 2 times 3, negative 6x. Negative 2 times 5, negative 10. Negative 2 times a negative 5 would be a positive 10. So we write all of them out. We multiply everything by the number that we have in the front. Once I do this, my x's, the same variable, same number, different signs. That's exactly what I'm looking for. So then you get rid of it. And then you just take care of everything the way you have with the other problems. 21 minus 10y, well, that's a 11y. 12 plus 10 is 22. We divide both sides by 11. So y is equal to a positive 2. So now I always like to take everything up to the top equation. We have 2x plus 7 times 2 in this case, because the y is 2, is equal to 4. So we have 2x is equal to 14, which is 2x plus 14 is equal to 4. I'm trying to solve for x, so the first thing I have to do is get rid of that 14 by subtracting it. 4 minus 14 is negative 10. So we divide both sides by 2, and negative 10 divided by 2 is a negative 5. So my answer would be negative 5 and positive 2. Now there's two other situations. And this is solving without, please add the word out, without unique solutions. Now, when we add without unique solutions, that means we're having a different situation. So we're going to go ahead and cover two different types where there is no unique solution for this. So the first one, negative 3x plus y is going to equal to a negative 5. And 3x minus y is equal to 5. Now, when you look at this problem, when you analyze it, look at the 3x and look at the negative 3x. What's going to happen there? They're going to cancel. Look at the y and the negative y. What's going to happen there? They're going to cancel. And that's exactly what happens. So that becomes a 0 because there's nothing left over. There's no x's, no y's, completely eliminated. Now, what happens when you work with the right side? Negative 5 plus 5. Well, in that case, that's going to cancel too, and it's going to become a 0. So that's a unique solution without an actual solution, because 0 is equal to 0. Okay? Now, here goes the other one. 4x minus 6y is equal to 6. The second one, negative 4x plus 6y is equal to 10. So let's look at it. 4x and negative 4x, well, what's going to happen there? Get eliminated. Negative 6y plus a 6y, what's going to happen there? Get eliminated also. So we end up with a 0 again. But in this case, on the right side, we have 6 plus 10. Well, that's not 0. That's actually a 16. So we're going to go ahead and analyze these two really quick. Let's look at the left side. Is 0 equal to 0? Well, yes. So this is always going to be true. 0 is always going to be 0. But when we look at the right side, is 0 equal to 16? That's always false. That's never going to be true. So 0 is 0, but 0 will never be equal to another number. So when we talk about solutions to linear systems, all the other problems we've done, we get a point. A point means there's an intersection. Well, in this case, when you end up with something where it's true, like 0 is equal to 0, that means we're ending up with the same line. When we end up with something as 0 is equal to 16, well, in that case, we end up with parallel lines. Now, same line would mean that we have infinitely many solutions. Parallel lines would mean that there is no solution. So, two different cases. One, that's true, infinitely many solutions, infinite number of solutions. 0 is equal to 16, always false, those right there have no solutions. So let's work on a problem like this. So this is the last example. We have example number 5. We're going to have 3x plus 2y is equal to 10, and 6x plus 4y is equal to 15. Now, when we start looking at these numbers, let's look at the x's. We have a 3 and a 6. The greatest common multiple between 3 and 6 is 6. The 6 is a 6. All we have to do is make that 3 a 6. And then we look at the 2 and the 4. Well, the 2 and the 4, I can make that 2 a 4 also. So how about we go for the smallest number, which in this case would be working with the y's. So we'll go ahead and try to make both of these a 4. Like I said, the bottom one's already a 4, so we just worry about the top one. So how can I make that 2 a 4? By multiplying it by 2. But keep in mind, you need one positive and one negative. So let's go ahead and multiply the top by a negative 2. When I do that, negative 2 times 3, negative 6y. Negative 2 times 2y, negative 4y. Negative 2 times 10, negative 20. The bottom stays the same, so I'm just going to write it down all the way through. Now, when we look at this problem, we're going to have one of these solutions solving without a unique solution. So let's look at the x's. We have a positive 6 and a negative 6. Well, obviously, those are going to cancel. We have a negative 4y and a positive 4y. Obviously, those are going to cancel also. And then we have equals to, well, let's see. Those two cancel, that's 0, negative 20 plus 5. Well, that right there is a negative 5. So, is 0 equal to a negative 5? That is completely always false. So if it's always false, that means that there are parallel lines, which means that there is no solution. Okay, let's analyze these two problems in this bottom left box. You don't have to write them down. It's just understanding who would you get rid of and why, and what would I have to multiply. So when I look at 2x and 5x, I am trying to go ahead and look at it. Same variable, 2 and 5 are not the same number, but what would be the common number between them? Well, it would be a 10. But then I look at 3y and negative y. Well, remember this is a 1, so between 3 and 1, what's the smallest multiple? A 3. I can make both of those a 3. Now, would you rather work with a 10 or a 3? In this case, I'm hoping you're thinking, hey, with a 3. So what would I have to do? Just multiply the bottom by a positive 3. Why only a positive 3? Because it's already a negative. So it's already going to be a positive and a negative. So let's go ahead and look at this problem in the bottom. Let's go ahead and make this guy a plus. So 2x and 3x. Common multiple between them, a 6. 3 and a 4. Common multiple between the 3 and a 4 is 12. Who do you want to work with, a 6 or a 12? I'm hoping you're thinking a 6 because it's smaller, and remember that's always the advice. Always go for the smallest one. So I would have to multiply this 2 by a 3 and multiply that 3 by a 2. But keep in mind, we need to keep one positive, one negative. So it really doesn't make sense. I mean, it doesn't make a difference which one you choose to multiply by, but I would just multiply the bottom one by a negative. So everything on top by 3, everything in the bottom by negative 2. So let's try a couple of problems. You're not going to have as many as for substitution, but you'll have a couple.